So yeah, I'm Harshit from Chaos Genius. We will be talking about open sourcing outlier detection and root cause analysis. So let's start with some background. One of the key things that's happening globally is that we are having higher and higher amount of data volumes because of these large data volumes. There's some estimate that there'll be 175 zettabytes of data volume every year by 2025. By some estimates, over 80% of the total data that is created was created in the last 2 years. Not just is the data increasing, but the kinds of data and the complexity of the data is also increasing. So, for instance, you have system matrix, you have telemetry data, you have user analytics behavior, and it gets harder to monitor, to understand, and to do a root cause analysis of all this data as the data becomes higher. So I understand that this is the talk after lunch. So a lot of you might be just a little asleep. So let's start with a small quiz. And I think you may have heard of the phrase "the curse of dimensionality." So let's start with a phrase around that, with a quiz around that. So let's assume that you are an e-commerce company. You are monitoring your revenue. You're monitoring your revenue, and you're monitoring your revenue by various product categories, like assume 50 product categories over 50 states, and 8 device plus OS combinations. So what would be the subpopulation? What will be the subpopulation, total amount of subpopulations or subgroups that we'll have, if you're monitoring this? Any guesses or thoughts? Yeah. So this will be A cross B cross C. So even for this very simple scenario where we're just looking at 50 states and only 50 product categories, we are not even looking at each SKUs. It still is 20,000 dimensions just for one metric, and it gets harder and harder to analyze it. It gets harder and harder to monitor it at scale if we with the traditional tools like Tableau and Metabase and Power BI. So that is where some of what we do comes in place. But before we do that, I'll talk about the curse of dimensionality. So with these huge number of dimensions, like we mentioned, it gets harder to monitor things either with BI tools or manually. If you want to also do things automatically on all dimensions, you need to have some understanding of the trends, the seasonality, and the finer behavior of each metric, which is not so trivial. And then the last point is doing a root cause of change. Why did certain things change? Gets pretty intractable with a high amount of dimensions if you have with the standard analyst tools like SQL and Excel and Google Sheets and so on. Right. So before I get into what we are, I would also very briefly talk about the landscape and where we come in the place. So we have most of our competitors are pretty heavily funded closed source companies. They have a reasonably high adoption friction. They are pretty expensive. Even as a baseline, you start with like say 50,000 USD annual contract value at the onset. And some of the people who have created these companies have pretty deep domain expertise. So they are founders of TensorFlow, founders of labs at Stanford and at UC Berkeley. AmpLab is the lab that created Databricks also for the context. So I'll very quickly jump into what Chaos Genius can do. And first is you can connect to a wide range of data sources, starting with data warehouses like Redshift, Snowflake, and BigQuery, and your databases, your columnar OLAP databases like Druid and Pinot, Databricks, and we also have an option to connect with third-party data sources like Shopify, Facebook, Google Ads, and Amazon, and so on. Now, once you connect your data sources, we support metric definition, so you can either define our matrix in our own in-house metric definition and management system, or you can also use DBT or other matrix layer to define these matrix and get an idea of them. Now, once we define these matrix, you can start seeing pretty detailed anomaly detection for all these different dimensions, as an example that we started with. So let's assume in this example we were talking of cloud cost for hourly data, and you see that we saw a spike, but we essentially are also looking at all the combinations of the data, and that is why we saw that the spike is related to AWS Lambda at this particular point in time, and region being EU Central 1. So this is the kind of anomaly detection that we can very quickly enable. We can also have root cause analysis with drill down. So this gets even more complex than anomaly detection, the multi-dimensional analysis that I talked about, because you are talking of combinations of data. So root cause analysis essentially here means is that why did a matrix change from A to B, and what was the real reason behind it? But to find the best possible reason for that, you're looking at a combination of data and not just a simple number of subgroups. So it gets even more complicated. I would not go into details. We can cover that in Q&A as to how that works and what kind of value it provides. Besides that, we also have, we wrap all of this with alerting. We have and alerting in a smart way, so that you don't have alert creep. In that you're not overloaded with alerts, and we provide standard alert channels like Slack and email and so on. So that's briefly what Chaos Genius is. Some of the technical challenges we face and where open source helped us was that we have to run hundreds of machine learning models over thousands of dimensions per data. These models could be statistical based or machine learning based or deep learning based. The software should work well, whether it's your laptop or a large cluster. We have to produce effective results with heterogeneous data across a range of verticals. And it has to be easy setup. It should be pretty much self-serve, because this is one of the things that we talked at the start, that that the competitors have pretty high friction. It's pretty hard to use them. So essentially, we used open source in a bunch of ways to build this product better in two broad categories. In that, we use a lot of available open source to jumpstart this development. Some of the companies that I talked about have been around for 8 or 9 years and are much more heavily funded. So so essentially, with available open source, we were able to build data loaders quickly. And we also built a framework in which you can add new data sources in a pretty easy manner. And on that same note, the ML models that are used for things like anomaly detection or outlier detection, we provide pretty detailed configuration, so you don't have to deal. In some other scenario, you will have to deal with a particular data scientist, or have to write some custom code to do the kind of stuff that you can do inbuilt with the tool. And obviously, open source helped with community and adoption for us. There was a lot of rapid iteration and user feedback. We got a lot of user and community contribution. And essentially, we were able to, I think we just launched 6 or 7 months back, and we were able to make this work in a large range of diverse use cases and a user base. So very briefly, we are now being used in over 25 countries. This is not the entire picture. And we have a pretty diverse range of contributors that we have been able to build, and who have helped us from building the core stuff. Some of my team members are here who helped build that, and then all the good things that come with open source. Some very quick success stories that I'll wrap up with. So there's a wide range of uses that are being derived from Chaos Genius. So one example would be a fintech company which is monitoring 1,000+ business KPIs, which was much harder to do. A lot of business metrics would essentially slide down and would get into a territory that was not comfortable. It was much harder to do it that way. There's a edtech giant which is measuring and analyzing data quality with us. There's a gaming conglomerate which is monitoring user behavior with with the OLAP data pipeline that they have. And we also have as an example, an IoT, New York-based IoT org that is using us to observe over 100 million. That is using us to monitor a lot of device deployments with over 100 million rows per day. So that's pretty much it. Do start it as Chaos Genius, and it's all open for questions. I did skip a few things in the interest of time, and I am happy to answer them right now. Any questions? Yeah. Sure.
I'm guessing your target customer is like the business team within a
business and data analyst teams.
Yeah. And what exact sort of advantage do they see of you being an open source or open core platform?
There are multiple things starting from initial adoption, which becomes much easier because it's open source. So often, as you know, that business teams have to get through a lot of permissions to even get the basic installation working. So that is the one thing with respect to starting of installation. And then we are not very tech heavy with respect to setup. So as an example, in Grafana, you have GQL that you need to do to set up alerts. We have tried to make a lot of that very easy on the user interface side with respect to metric definition, as well as on the what you can do with models. So you don't need a detailed data engineer or data scientist to set it up and make it working at a reasonable level.
Hey, hi. My question is like, see here we need to play with lot of data. So like, question is about like, how do you test the data here?
We were lucky because we had these initial pilots where we were able to fine tune how our models are working in those thresholds. But because these are purely on-prem deployments, we don't live test the data for a customer, right? So if that answers your question. So essentially, the whole software is running in the customer's environment. If customer faces some issues, or if the deployment faces some issues, they come back to us with, say, logs and some other information about their metrics, and we then help diagnose it and suggest what you can do. Yes, right.
Any more questions? Hi, Harshit. Good talk. So I had a couple of questions. One is on the domain. Like, are your algorithms generic, or are they like tuned to your domain? How do you make sure that they work across domains? That's one. And if they work across domains, let's say if I see an anomaly, is there any kind of explainability kind of
yes.
Mechanism that is built into, or you're planning to build into that?
Yes. So I'll start with the second question first. So yes, we have a basic explainability wherein you can drill down in an anomaly and understand what were the key factors with respect to some drill downs. This is basic because it works on just correlation. We are building some more deeper causal models so that there is some more deeper understanding as to why that anomaly happened, and also to the level of why is something even an anomaly, because right now we are just giving a severity score, as you can see, and severity score may not just be a good measure. So that's the first. Does that answer your question? For the second, for the first question, so right now we have all generic models. They are not fine-tuned to a particular domain. However, in certain cases, when we are working closely with a customer, we have rolled out some specific models and specific hyperparameters for that customer. So that is how we have done it. So we understand the data, we have rolled in a new model and fine-tuned the hyperparameters for them. But we don't have models that just work on e-commerce or retail. It's all about hyperparameters.
Hey, hi again. Like when we find out that anomaly happened and found out that what is the root cause, what will be the preventive action later on?
So that's a great question that has been asked from us often. And right now we don't have anything on the preventative action. There are certain things in our roadmap that we are working on that is like a beacon kind of system that will help you predict if something is going to be towards a track of being an anomaly or not. But right now in the open source version we don't have anything. But you can think of it like, say, on a very high level, like predictive maintenance. If you have all these parameters, can you predict if something is going to go wrong? Are we done?
Okay. Any more questions?
Yeah. Thank you, everyone.